is that I have a ski jumper, coming down, and then he takes off at some angle, and I'm saying that he's going to leave at 20 meters per second at a 20-degree angle, and then the hill is a 3-4-5 triangle. So the question becomes, where does he or she land? So like any of these problems that we've done so far, the first step is to write position of the skier as a function of time in the x direction, position of the skier as a function of time in the y direction. And so, and then once we've done that, we come up with as a function of time, if I know the x position, I know how long he or she has been traveling for. So with that, I can come back to this initial y equation and plug that in and get an equation for the skier that says, which is an x as a function of time equation. And so now I have basically two lines. I've got a line that looks like this, which is the ski slope, and then I have a line that looks like that, which is the skier. And then the question becomes, at what point do they intersect? So I'll set these two equations equal. Just as a reminder, I have, if this is a 3-4-5 triangle, then basically, effectively what I have is an equation of the form y is equal to mx, and in this case, y is equal to minus 3/4 rise over run times x. And so what I've done is I've taken this y, set it equal to that y, and then made the assumption that the initial height is 0. And then at that point, it just becomes a matter of substituting in what I know. So I know you end up with this V0 sine theta over cosine theta. That goes to tangent. This comes over here and goes to x squared v squared over cosine squared of theta. And if you go through all of this, there actually turns out to be two solutions. One is if x equals 0. The other solution is x equals 78.7. And then you ask yourself, hold on a second, does that make sense? And I say, well, is 78, so if 78.7 is my x position, that gives me a time of 4.2 seconds. Plug that 4.2 into my y equation, and then what do I end up with for y? I end up with 59.5 meters, and then I can confirm that that fits the equation. Y is equal to minus 3/4 x, and then plug those in, and it works. Yes, your question.
But isn't the initial position of y 0, isn't that 4?
That's a great question. That is for the problem I was just doing a general problem. That I thought this problem in some ways, well, they're just different problems. Any other questions? Anybody want to say hi for the camera?
Hi, camera.
Okay, there you go.